Welcome to this session. Here we evaluate the integral of square root of 4x squared plus 20 dx. So to solve this, observe that square root of 4x squared plus 20 is the same as the square root of 4 into x squared plus 5. And you see, from basic algebra, square root of AB is the same as root A times root B. So this is the same as root 4 times root x squared plus 5. Root 4 is 2. Root x squared plus 5, which you can write it as 2 root square root of 5 squared plus x squared. And now, because there's existence of this radical of this form, so since a radical of the form square root of a squared plus x squared exists, then we make the trigonometric substitution of x equals to a tan of theta. So whenever you have a radical of this form, then this is the correct form of the trigonometric substitution. Now, square root of a squared plus x squared, if we relate to what we have as root 5 squared plus x squared, then this implies that a is root 5. So which means that the correct choice, so therefore we use x equals to root 5 tan of theta as our substitution. Now this implies that dx is root 5. Differentiating tan, you get x squared theta d theta. Now the square root of 5 plus x squared is the same as the square root of 5 plus squaring this, you get 5 tan squared 5 tan squared of theta. I'm squaring this x value, which is the same thing as factor 5 1 plus tan squared theta, which is square root 5 1 plus tan squared is sec squared, and this will give us root 5 sec theta. Now with that, then the integral of square root of 4x squared plus 20 dx will be, now remember, before we go to the 5 plus x squared, we had a factor 2. So it's the same as 2 integral 2 square root of 5 plus x squared dx, which will be 2 integral. This one, its value is root 5 multiplied by sec theta, and the x from our calculation is root 5 sec squared theta d theta. That's what we have. So root 5 times root 5 is 5. 5 by so this is the same as 2, and then times this by this is 5 square root of sec cubed theta d theta. So this is the integral of square root of 4x squared plus 20 dx, which will give us 10 integral of sec cubed theta d theta. So now the problem reduces to calculating the integral of sec cubed theta. Now for us to carry out that integration, we'll use this reduction formula, which we have derived before. Sec power m x dx is given by tan x sec m minus 2x, and then over m minus 1 plus m minus 2 divided by m minus 1 integral of sec power m minus 2 x dx. This is the reduction formula for sec power n function, or sec power n integral. So our interest is to find integral of sec power 3 theta d theta. This will be tan of theta. Sec 3 minus 2 is 1 over 3 minus 1 is 2 plus 3 minus 2 is 1. 3 minus 1 is 2. Now 3 minus 2 is 1. So this is the integral of sec theta d theta. Now this will give us tan theta sec theta divided by 2 plus, when you differentiate a sec function, you get ln sec plus tan function. And then we add a constant of integration c. But remember, we had a 10 as a coefficient outside this integral sign. So this implies 10 integral of sec cube theta d theta will be 10 into tan theta sec theta divided by 2 plus a half ln of sec theta plus tan of theta, then plus c. So which will give us 5 tan theta sec theta plus 5 ln of sec theta plus tan of theta, then plus constant c. So this is the same integral of square root of 4x squared plus 20 dx. But remember, theta was not in the picture, so we have to change all the values. So we know that x is given by, from what we have fixed, root 5 tan of theta. So this means that tan theta itself is the same as x over root 5. Now you draw a right angle triangle. Let this one be theta. Tan is opposite over adjacent. So this is the square root of this squared is 5, and then plus x squared. That means sec theta. Sec is reciprocal of cosine. Cosine is adjacent of hypotenuse, so sec will be hypotenuse of adjacent. So square root of 5 plus x squared divided by root 5. So replacing into the value we have gotten as our integral, this implies that integral of square root of 4x squared plus 20 dx is 5. Where the tan theta you put x over root 5. Where the sec theta you put root 5 plus x squared, or root of 5 plus x squared over root 5 plus 5 ln of sec is square root of 5 plus x squared divided by root 5 plus tan is x over root 5, and then you add a constant of integration c. This simplifies to, now root 5 times root 5 is 5, so 5 times this 5 cancels out. So we'll have x square root of 5 plus x squared plus, now this one we can write it as 5 ln of, they have the same LC denominator, so root 5, then root of 5 plus x squared, then plus x. But you see, we can write this as, so this solution can as well be written as x root of x squared plus 5 plus 5. Now ln of, these are quotient, so root 5 plus x squared plus x minus ln of root 5, then plus c. Remember this, just loss of logarithms. So IE, and you see root ln of root 5 is just another constant. So this we can just call it, say C naught, or K or A. So therefore, the integral will be x root 5 plus x squared plus 5 ln of square root of 5 plus x squared, and then plus x, and then this one you call it constant A. So that is the final solution to that given integration problem. So this is the final solution. Thank you.